So thank you, everyone, for joining me today for our July CATIpult session discussing design tables and configurations. My name is Chris Dubuque. I am one of the application engineers. I'm located out in the Northwest, out in our Oregon office. All right, so let's go ahead and get into this. I just want to make a quick comment that, yes, my title is a little bit different than maybe what you had initially expected, where it was only to cover design tables. But as I started thinking about putting the content together, it's a little bit difficult to discuss design tables without at least touching on configurations. Because if you are familiar with this functionality in SOLIDWORKS, you cannot have a design table without a configuration. They just go hand in hand. So, I've got about 45-ish minutes of content to talk about, and really wrapping up everything about design tables. So I am going to start a little bit about configurations. I am going to go through a brief example of manually creating them. What I've found is typically we get a large, diverse background of SOLIDWORKS users. So while you may know configurations quite well and design tables quite well, we may have some people that have really never dove into this kind of functionality. So we'll talk about, why would we want to use them? A few little things to look out for when looking at and leveraging configurations. Again, I'll go through hopefully a brief example of, I'll say, manually creating a design table in SOLIDWORKS. You can also manually creating configurations, and then I'll get to design tables. But you can also create configurations using what I just simply refer to as a configuration table inside of SOLIDWORKS. And I'm not going to go through a live example of that. I'll just throw up a couple of screenshots to familiarize yourself with that functionality. And then we'll get to design tables. They're formatting, the content, and the parameter that we can control. We'll go through an example of creating and editing design tables, and kind of wrap up with how do we put this design table information in drawings. Talk about cleaning up that table, a little bit of formatting, because if you've tried to do this on your own, you might have noticed it's a little bit awkward. So we're going to cover a couple of different topics today, not just design tables. And I am going to keep it more, to the simple side of things. So if you're looking for more advanced design table functionality, we've got you covered in our October webcast. We're going to have a really in-depth webcast in that month to go deep into design tables. But let's go ahead and talk about this. So real basic configurations, and I'm going to be strictly discussing part-level configurations, but they do work for assemblies as well. But it's old functionality. It's been inside of SOLIDWORKS for as long as I've been using SOLIDWORKS, which takes me back to, I think, SOLIDWORKS 99. So, kind of core SOLIDWORKS functionality. And it's just the ability to create different versions or geometric variations of a design, and all that data is stored in a single file. And that's kind of an important piece of information, as we'll see. Typically, we build these configurations through feature suppression, which to suppress a feature, if you're not familiar with that, is to turn it off so it's not calculated or evaluated in the manager tree anymore. Another very common aspect of configurations is to control dimensions. So we can have dimensions that are evaluated to some number in configuration A, and that same dimension is evaluated to a different value in configuration B, and so on. Now, that's not all you can do, but that's kind of the basics of it. Now, as we take a look at those little rocker arms, and that's the example that I'll be showing, we've got these three different similar versions, but they all share that same feature manager tree. And that's, again, kind of an important aspect of this. If you delete a feature in the tree, it's deleted out of all the configurations. That comes up from time to time. So in this little example here, we've got a handful of features in yellow. Those are unsuppressed or being evaluated in our little rocker arm plate. And the features in gray, cut, extrude 4, 6, mirror 1, etc. Those are suppressed or no longer calculated. And the configurations essentially just bounce from one set of features being calculated to another set of features being calculated. in the end, it can be as basic or as complex as you need it to be. So why do we use them? Why do I like to use them personally? Just design reuse. Leverage as much as you can to build that family of components. It does end up giving you less individual files to manage because those variations are stored within the file. But again, having everything in with one file can lead to just some things to think about that I'll talk about in a few moments here. Another big use of configurations is performance. If you have a part that has some really heavy features and takes a very significant amount of time to rebuild, you can suppress those features, and that'll increase the rebuild time, or I should say decrease the rebuild time. What about manufacturing operations? We see this quite a bit. A configuration to represent maybe a more raw forged part, or maybe the blank that we're getting from a material vendor, and then a configuration to show a rough machining operation, a couple of intermediate operations, and a final machining operation possibly. Another aspect we see for these manufacturing operations are sheet metal parts, a process plan for the bends, various bends to represent the model going from the flat to the fully bent state, different configurations activating various bends. Simulation, I use configurations quite a bit when I'm doing simulation studies to suppress the features that are not critical to the strength of the model. Things like cosmetic fillets are notorious for causing, increased time in meshing the part or assembly, increased time in solving it. And this maybe kind of kicks back to performance, just removing features that they may look really nice, and yes, they're going to be manufactured on the finished part, but I don't need to see them, or I don't need to have the software calculate them all the time. And kind of the example that I'm going to show here today are what-if scenarios. I just want to try a couple things out. I'm going to use some configurations to see if they work, and if they don't work, delete the configuration. But if they do work, then I can easily leverage that configuration. Works out nice for assemblies because I don't have to swap parts around in and out of an assembly. I don't have to worry about, if the part's too drastic, maybe some mates are broken. It's the same part, just switching configurations. Things tend to rebuild and update nicely in stride with that. Now, a couple of things to watch out for. I mentioned this a few times, but again, the more configurations you have, because all the data is stored within the single file, the larger that file becomes. And you can almost think of it as files within a file. That's not 100% accurate. So for example, if you have 15 part files, and they are each 1 megabyte, yeah, we add those up, we've got 15 megabytes worth of data. Those are pretty small part files anymore, though. But if I had one part file with 15 configurations to represent, those 15 individual files, if it was a family of parts, it wouldn't necessarily be the exact same as adding all of those, those file sizes up, but it's going to be close to it. So that's something to think about. The more configurations you have, the larger the file is. If you have parts with hundreds of configurations, that could be a very, very large part file, and have to deal with it that way. The other thing to watch out for, I see this quite a bit. It's kind of a joke that I have up there, but really significant model changes. You don't want to configure an end wrench into a hammer. Maybe an end wrench into different sizes, or maybe a box end wrench to an open end wrench, for example, or maybe different styles of a hammer. But even though it's allowable, the software allows you to basically configure any part into anything else, there is a limit where it's more appropriate to make a new part file as opposed to make a configuration. It's a pretty big gray area, and it's one of those things that you tend to learn as we go with configurations. But again, you don't want to configure an end wrench into a hammer or vice versa. Another thing to think about is kind of categorize them under workflow changes. I'll use that example of 15 discrete part files now into one part file with 15 discrete configurations. You need to think maybe a little bit about, well, we've got these less files to manage. How do those integrate into our PDM system if we're using one? How are we going to leverage the configurations in different parts, different assemblies, different drawings? If you use SOLIDWORKS file properties, you need to be aware of configuration-specific file properties, because each configuration can have its own properties that will override the overall part configuration. I know that's a lot to say right there, but again, with trying to get a lot of power out of configurations, there's a few things one needs to think about. And last but not least, not every part needs configurations. Not every design you do is going to be highly configurable. Not every industry, really needs configurations, especially if you do a lot of really custom fabrication and one-off type work. Yeah, maybe this isn't the most useful every day, but it's something that may pop up from time to time to leverage. So when we're talking about, again, I'm going to focus on part configurations today. What can we control? Well, what I've highlighted in red are what I see utilized more than any others, kind of the core capabilities of configurations, and that's to suppress features or turn them off, unsuppressed to essentially turn them back on. Of course, dimensional values are right up there, kind of 1A and 1B that we use configurations for. Also, because design tables build configurations, it's the exact same when we get to the tables, as we'll see. Materials, you can have configuration-specific materials. And again, those configuration-specific custom properties, those are configurable. Now, that doesn't mean that's the extensive list, and nor is what you see on the screen the absolute extensive list. You can also configure relations or feature in conditions or the definitions of sketch planes. Colors, I don't do that quite a bit because I tend to configure materials, and the color just kind of falls out of all of that. But mass properties, equations, variables, et cetera, et cetera. Now, just from personal experience, I tend to maybe stay away from configuring my sketch relations. It is functional. You can suppress and unsuppress sketch relations. But I personally, again, just my opinion here, find it easier to control that behavior with two different sketches, for example, and then simply suppress and unsuppress those two sketches to get the behavior of different different relations. Same is true with in conditions. While it is very easy to have a cut extrude in configuration A be solved through all, and configuration B, have a blind cut depth, maybe it's a little bit easier in your case to just have a couple different features and suppress and unsuppress them. So this also falls under the category of just because you can control all of this, it doesn't necessarily mean that it's the only way or it'll work the best for what you need configurations for. So how do we build these configurations? Again, manually. I'll go through a quick example leveraging the Configuration Property Manager. I'll talk about, again, configure features. Right-click on a feature, configure that feature, or right-click that dimension in the right-click menu. You'll see those pop up. Configuration tables are very handy in my opinion. But remember, or maybe you've never even heard of this, just be aware, you can save the table views so you can get back to that view, and I highly recommend to do that, and I'll emphasize that a couple things. And then finally, design tables, that Excel spreadsheet built inside of our SOLIDWORKS models, and they really cover everything from basic configurations to very complex configurations, a couple configurations to hundreds of configurations. The beauty of Excel is all the copy and paste functionality, the programming, the equations. I mean, if you are an Excel guru, it's pretty amazing what one can do with an Excel-based design table. Personally, I keep them simple. I use them for maybe fewer configurations, but I think they work best for multiple configurations because it's a nice, clean table, really makes it easy to understand what's going on and to control, again, a large amount of data. So building configurations the old way, the manual way. Switch to the Configuration Manager in the tree, right-click on the file name there, add a configuration, and give it a unique name. And that unique name is really all that's required. The description is optional. The checkbox to use in the bill of materials will do just that, give you a nice description in the BOM. Comments are optional as well. One set of of functionality in the bill of material options, or are the bill of material options, they tend to get overlooked. I see this question and I hear this question quite a bit. If you've got a part, with 5 configurations, it's going to be initially itemized as just the part name. So it'll show up once in the BOM and maybe an instance count of 5, for example, if we're using all 5 configurations. We can switch that so the software will itemize out the configuration name or itemize out the user-specified name, which allows us to type in whatever we want. So this, again, just gives us more control on how we want to think about configurations in our bill of materials, how to keep track of that data. And then the advanced options, and I have no idea why they're called advanced options, because I don't think they're too advanced. The one that is checkboxed by default, I personally just keep it that way to suppress features. Not super descriptive option, but what that means is when we build a new configuration, we are going to be in that active configuration. And if we add a feature to that active configuration, it's automatically suppressed for us in all of the inactive configurations. So it allows us to build a feature or add a feature to essentially one configuration at a time. Use configuration color, simply that. Tick the box, choose a color, and you can have blue configurations and red configurations and purple configurations and whatever it is that you need. And that last option down below, add a rebuild/save mark. That'll just cache the rebuild data for that configuration. That really only applies when you first open a part and first switch to that configuration. If that checkbox is on and that data is saved, it'll switch faster. If it's off, it may take a few seconds for the software, maybe a few minutes if it's a really complex configuration, to rebuild that configuration. From that point forward, though, that data will be cached for the rest of that SOLIDWORKS session. So that rebuild save mark doesn't really hurt you too much, again, unless you have really big parts, really big configurations, and you want to, speed things up at the beginning. So continuing to work through this creation of manual configuration. So we build the configuration name in the configuration manager. I like to switch back to the tree, suppress and unsuppress the features through the pop-up menus, the right-click menus, or the edit pull-down menus. Double-click on a dimension, change the modify, or the value in that modify box. But this is where I recommend hit the brakes, because I've been burned by it, and all the AEs I work with I know have been burned by it. Many users I talk to have been burned by it as well. And that is the default condition in the dimension modify box in a file that is configured. So by default, and this is not something we as users can change, every single dimension is going to be set to this little button there, which corresponds to all configurations. So if you get in a little bit of a hurry, like I definitely have done in the past, and you make a change and it's set to all configurations, that dimension may have just kind of blown out through many more configurations than you would like it to go through. So if you're going to make dimensional changes, again, just double-click on the dimension to change, type in the value in the modify box, but I do recommend just really try to slow yourself down, click this button right there, and maybe change it to a more appropriate option, such as the this configuration or specify configurations. Again, in the tree, choose a material to modify it, and then I say rinse and repeat. Switch back to the configuration tab, make a configuration with a right click, add a name, switch back over, and you essentially just go kind of back and forth, back and forth, back and forth. It's not the most streamlined workflow, but it definitely gets the job done. So before we get into it, I do have a couple of tips about configurations and all that good stuff. One is to create a configurable model, or maybe think about that a little bit. So we've got this wheel, not a super complex part, but we've got a pattern of holes in there. We've got a bore through the center, a handful of fillets. Depending on how we like to model, maybe our feature manager tree looks like this: one revolve and one cut. While it definitely gets the job done, and it's definitely a nice, compact feature manager tree, it really doesn't afford us much flexibility when it comes to configuring this part or creating our design tables. Now, if we take a look at example The next one there, same part, but instead of one revolve and one feature, we've got one revolve, 4 cuts, a pattern, and a discrete fillet feature. Maybe you wouldn't think about building parts that way. If you're like me, you really like to compact the tree down as much as possible. But if you want ultimate flexibility for configurations, your parts will have more features, and you may break something into multiple sketches, multiple features, multiple fillets, multiple patterns, so on and so forth. The other thing, yes, I know I just mentioned this, but I feel quite strongly about this option, is watch that dimension modify window. I've put up a couple of enhancement requests. I asked maybe note these down, vote for these, please. These are a couple of enhancement requests to change the default behavior of this modify box. One is to set the quote-unquote this configuration option as the default. The other is to allow the end user to make the change. So again, it's one of those things that maybe it only bothers me, and that's why these haven't been implemented. I don't think that's the case, but again, just watch that dimension modify box. Test your part for rebuild errors, because in the end, that's all configurations are doing, changing dimensions, changing features, and rebuilding your part. So you need to make sure that you've got a nice, robust part with some really good design intent into it. Watch those parent-child relationships. If a parent feature is suppressed, or again, shut off if you're not super familiar with that terminology, the child features will also be suppressed. I do recommend, if you're new to this, to start slow and add complexity. I've worked with many a customer over my years, many a user of SOLIDWORKS. I've kind of fallen into this trap myself of really getting in over my head. Maybe I started to run before I'm really walking or crawling even with the part, and tends to not end too well. So start slow, add complexity as you need, and like all things, I always like to mention, just have a plan. Kind of think about what you want to accomplish with this part. Why am I really using configurations? Again, just because I can, maybe it's not appropriate in this instance. So enough of me talking. Let's look at a simple example. So as we jump into SOLIDWORKS here, we've got the drivetrain to the mountain scooter, all-terrain, gas-powered vehicle of craziness, if you've seen those videos, if you've come to some of our other sessions. It's a gas-powered, basically tank tread skateboard that's all-terrain, kind of a crazy invention. And what I want to think about here are these rocker wheels. Maybe you want to look at some what-if scenarios of those parts. So we'll just open that part up, zoom to fit with a double click of the middle mouse button. And before I get started with configuring it, I do want to point out the feature manager tree, because I did attempt to break things down maybe a little bit more so than we normally would. And for the sake of time, I have all the features in the part so we don't spend a lot of time watching me build sketches and things like that. Now, I will also say that when I originally built this part, I had the features for Cut Extrude 1 and Cut Extrude 2. There you can see the main bore and the smaller holes for the little bogey wheels. I had those in one sketch and one feature, which come to find out, it's not too configurable if I want to individually control those holes. So I had to make a few design changes, a few modifications to the part, and separate them out. Now I'm going to go through just to kind of set the stage here and unsuppress a few features. I've got Cut Extrude 5, which is that large cut you can see there. And all I'm doing is just clicking on them and toggling the little suppress and unsuppress icon. I've got some angled slots that I want to try out, for example. Suppress that. And then finally, I have some vertical slots and the corresponding mirror feature. So realistically, what I'm doing here is basically what my configurations are going to do. Just kind of toggle those back and forth. Had a quick comment about the parent-child relationships. There we can see the parent arrows, the child arrows. You can get those by right-clicking at the top of the tree. It's called Dynamic Reference Visualization. I don't think they could have come up with a longer name for that, but there we've got for the parents and the child arrows. So that's what we see popping up here right there. So here's a good example of suppressing a parent feature. Notice the mirror automatically suppresses as well. Now, while I was using the feature manager tree, just selecting and clicking the little pop-up menu, suppress and unsuppress icon, you can also get to these same commands with more capabilities from the edit pull-down menu. We have suppress, and even though it's grayed out, this all are specified configurations, unsuppress, this all are specified, and then finally unsuppress with dependents. So this will unsuppress the parent and its children. So that's a nice little option right there. Now the other options aren't available because I don't have any configurations yet. So I'll switch over to the configuration manager, right-click on the name of the part, add a configuration, and give it a name. And I'm going to start off, and let's just build, I'll say, the blank. Again, description, optional, optional, optional. Maybe I do want to leverage the unique bill of materials options here, and I would like to call out the configuration name in the BOM. Just choose it from that drop-down. I will not make any changes down below. I like that suppress feature, so I'll keep it on, and we'll say OK. The blank configuration is essentially a copy, and that this is going to work the same when we get into design tables. Whatever's active, that data is just copied forward. Switch back over to the feature manager tree, and now what represents the blank? Maybe I want to turn off or suppress cut extrude 1 and cut extrude 2. I'm control selecting them and suppress, and there you go. There's a configuration. Switch back over to the Manager tab for configurations, double-click Default, and then double-click Blank. Now I'm going to base a couple of other configurations off of default, so I'll double-click to activate it. Again, right-click Add Configuration, and give it a unique name. And let's build one that shows us those large cutouts. And again, let's itemize the BOM or make the BOM show up that large cuts configuration name. Now, if this was a complex part, it might be fairly difficult to figure out what features represent the quote-unquote large cuts. So another tip I have or recommendation with configurations and design tables is to rename your features. And that's just a click, pause, click on a feature, or select it, hit F2, does the same thing. It can be a lot more efficient to pick the feature or group of features out of the tree if you've renamed the ones that you think are important. Now for now, I'm going to just grab cut extrude 5. I know what it is. Right-click on suppress, and there's a new unique configuration. So just to recap, there's the blank. Helps if you actually double-click there. There's the default, and there's large cuts. And I could continue this process, over and over and over. I'll build one more configuration, though, and what I want to do is just make a dimensional change. And we'll call this one wide cuts. Not a super creative name, more descriptive than anything. But now what I want to do is take what we see on the screen and just make a wider version. I need a little bit more span for those bogey wheels. So we do this by, again, just changing a dimension. And you don't have to think about a different workflow. Double-click the feature that contains the dimension, double-click the dimension that you want to change, and change these options right here. This, all, or specified. Again, make sure you double-check and set this to the this configuration option. I'd already had the part open and was playing around with it, so that's why it was the way that it was. But every other dimension, it's going to be set to the all configurations. And simply type in a new number. We'll make this one 5. Hopefully it rebuilds. Control-B to test it, and there's the wider version. There's the narrower, a little bit wider. Double-click default, double-click blank, and essentially this cycle continues. We just keep working with this as much as we need. Maybe we want to think a little bit about, let's go to the default here. What are these parts made out of? Maybe we are going to have different configurations of different materials. Again, build your configurations and just simply change the material. say yes to line up all the appearance data, switch a configuration. Again, I'm not using the most efficient method by toggling back and forth between the tabs on the tree, but as you can see, let's make this one copper. That's really all you need to do. Materials are configurable just like any other feature. And when we get to the design tables in just a couple of minutes, you'll see it's the same. So these manual creations, they're pretty easy to get the job done, pretty easy to create. Maybe a little bit awkward, bouncing back and forth between the trees, but it's a tried and true method, that's for sure. I do want to just emphasize again the options to control that part number in the bill of materials. And in the end, the complexity is it's up to you. How much do you want to put into your model? Now, another way to kind of bridge the gap between the manual configurations and what we'll see here in just a minute of design tables are these configuration tables. And they're not really a command called table, configuration tables, or anything like that, but they're built by right-clicking on features in the tree and choosing configure feature, or right-clicking on dimensions and choosing configure dimension. You can do the same with configure material or configure component at the assembly level. And what will get built is this nice little kind of internal table. Once we jump into design tables, you'll see that there are some similarities of where the data is placed and how it's formatted. Some functionality is also the same between them. So we can add extra features to control whether or not they're suppressed or unsuppressed by just double-clicking them on the tree. We can double-click on dimensions, and the ability to control that dimensional value is also added to these tables. And in the column here where it says configuration name, basically a cell, just click in there, type in a new name, and that builds a new configuration, and hit the appropriate checkbox for suppress and unsuppress, and make the dimensional changes. So they are quite useful. Now, they do come with one pretty significant caveat, in my opinion, and that is these table views are not saved by default. So if you're building a very elaborate table through this modify configurations functionality and you say OK, you're not going to be able to easily get back to that view. So what I recommend is, if you venture down the road and use these, which I personally find quite useful, make sure you key in a name. It's not super intuitive on where you go, and then click this button right there. Make sure you save that view. And you can save as many views as you want, and then you can recall the view in the tables folder. It's going to look just like a design table. Right-click, edit the view, edit the table, and you can get in there and start making changes to it. But again, any change you make, you have to resave that view. So it will not save it automatically even if you've created it. So now we get to design tables. So thank you, everyone, for your patience while we get here. This is to leverage the power of Excel to build our configurations. With that said, you do need a license of Excel to use to use design tables. You do not need Excel to simply build configurations, nor to build the internal configuration tables that SOLIDWORKS provides. But if you need Excel power, you need a license of Excel, and it only works with Excel. You cannot use any other spreadsheet application. So thinking a little bit about prepping a part or just any model for design tables. This is really true. I'm kind of reiterating some bullet points here. But you need to make sure the part can survive the changes. If it rebuilds in SOLIDWORKS correctly, you're good to go for a design table. If you get rebuild errors in SOLIDWORKS, which is making a dimensional change, you probably should fix that before you start to think about design tables. Even though I don't do it all the time, it is useful to rename features to suppress in the tree, also rename dimensions that you'd like to modify. There are options to show dimensions through the annotations folder in the tree. Turn on the option to show dimension names, again, just to differentiate one dimension from another. And this is no different than what I mentioned earlier. Start small and build up. Again, have a plan. Now, specific to design tables, save a copy of the table. I'll show you how to do that, and if I forget, I've got a screenshot of it in my last slide. I've seen many cases where the design table is the design. It becomes so complex and so powerful that it really is more important than the CAD model to some extent. And if anything happens to that Excel spreadsheet, because these are technically stored inside of our SOLIDWORKS models, if that design table becomes unable to open or something like that, that's not a good situation to be in. So you want to make sure that if you do get deep into design tables, and it's a very complex table, especially with formulas and maybe lookup tables and cross-references and concatenation functionality and all that, very powerful Excel functions, save that table, make a backup of it. If you use PDM, rev it in PDM just like anything else. It's just as important as the CAD data itself. So when we start thinking about these design tables, because it's Excel-based, it is extremely organized. And with that organization means data must go in very specific locations. So configuration names are in column A, starting by default with cell A3 down through column A. And the parameters to control, the features to suppress, or the dimensions to change their values, those are in row 2, starting with cell B2 and on through up the alphabet. Cell A2 in an automatically created design table is the family cell. That's special Excel functionality. You do not want to modify it. It needs to stay intact because that tells SOLIDWORKS, well, the configurations are below this cell and the data is to the right of that cell. Now, if you're really familiar with configuration, Excel and family cells, you can really set any cell to be the family cell, but that's what SOLIDWORKS is looking for. So I recommend just, kind of leave it alone until you get really comfortable with it. So creating a design table, quite easy to do. Insert pull-down menu, tables, design table. And then we'll get this little window that pops up that'll allow us to build a blank table, an auto-create table, or browse and bring in a table from file. So blank is, again, just that. An empty spreadsheet, we start populating it. Now, auto-create is what we tend to use more than anything anymore inside of SOLIDWORKS. And you really have 2 options, and that depends on whether or not your part has multiple configurations. If it does, like we see in the screenshot, SOLIDWORKS will extract all the unique configuration data and parameters and place all of that information into the table automatically for you. So it really takes auto-create to the next level. That's really what it comes down to. Now, if your part only has one configuration, the default, which all parts and assemblies have, you'll get a window to select dimensions to auto-add to the design table. Whatever dimension you select, that's what you'll get in the table. So it gets you started, but it really comes down to how much have you built previously as far as configurations are concerned. And then from file. Typically, you browse to that external file. It does give you the nice option to link to that external file, but then again, make sure that external file is protected, because if that external file gets, quote-unquote messed up, well, the next time that part file is open and that data is going to be read in, it could cause some significant problems. So options for a design table. It really comes down to allowing or blocking this bidirectional update. So for all design tables, any change we make always propagates from the table down to the part. But if we have the allow function on, we could change the part, maybe a dimension or unsuppress a feature, and that change will propagate back up into the design table. There's options to auto-add new parameters, and we'll see this pop up in a couple of examples. I tend to leave those all on personally, except I may turn off the cell drop-down. Sometimes where it says maybe slower, it's significantly slower. So, it's an option. You can see how it works out for you. And then finally, the warning. This is what you'll see if you have the allow model edits on, which I will keep on, so we will see this pop up a couple of times. So design table editing, because we're working with this very, kind of rigid environment, where you have your mouse cursor, what cell you've selected, is pretty important. I've run into many cases where people can't add data to a design table. It's because their mouse, and we've accidentally selected, some cell down here where the next cell in that row 2 must be selected because that's where the data needs to go. Double-click to add a dimension to that particular cell. Double-click on a feature to add it to the table, and that gives us the ability to suppress or unsuppress it. So it does really matter where we put our data in, and then simply type in a new name in column A, and that signifies build a new configuration. So when we talk about controlling parameters, we've got a few parameters that are unique to parts and some that are common between parts and assemblies. I don't expect anyone to remember any of those little code pieces, the parameter syntax, but this is what we'll see populate the header cells and what the appropriate data, what the value is appropriate for. Now, you can get to this by going to the SOLIDWORKS help. And I would recommend taking a look at it. Here you can see, just search the online help, which is help.solidworks.com. Summary of design table parameters. And you could, maybe brush up on some of this if need be. But again, it's just to let you know that I'm only showing a small piece of the puzzle, but also that this syntax is very important. You need the dollar signs, you need the ampersands, you need the underscores, but case sensitivity doesn't matter. But everything else, again, really does. So again, that's in the help. You can get it online, summary of design, table parameters. So let's build some. Let's jump back into SOLIDWORKS and let's look at how we can build some of these design tables. So let's take a look at this example to begin with. This is our part that we just built. It has 4 existing configurations in it. So if we go to the Insert pull-down menu, choose Tables and Design Table, we'll see those options that I had screenshots for. I will turn off Enable Cell Dropdown. Everything else I'm going to leave as is. We'll leverage Auto Create, and SOLIDWORKS loads Excel up inside, and all the information that makes each configuration unique is automatically added in there. You can resize the tables by grabbing these little grips. Be very careful. They're easy to miss, and the second you click outside the design table, well, that happens. It just disappears because it builds the design table. To get back to the existing, expand the configuration manager, expand the tables, right-click, and then we can edit the table. So we can see what SOLIDWORKS has done for us automatically. It's captured all of the names. It's captured the description. Let me make that a little bit bigger. So we'll just bump the fonts up here. There we go. Do need a little bit of cell formatting. It's captured the property for the color. And notice these are all dollar signs. So dollar sign description, dollar sign color, dollar sign part number. Again, it's all inside the help if you really want to dive into it. And we can see some large values for the colors. And those are the 32-bit integer values for the colors. There's calculators all over the place. It's pretty easy to write a formula to transpose the RGB values to here. But we'll just leave that as is. The material data is brought across. The part number data, it cycles between $D, that description property, $C, the configuration name. So again, just different information there. And then the dimensions, the state, et cetera, et cetera. So it's a pretty nice way. It really adds it in there nicely. If we wanted to add an additional configuration, we just type it in. Maybe we're going to create a configuration with the vertical cuts. And this is, though, where it can get a little bit tricky, especially since I've made the design table enormous, because I don't remember, again, what is what with the vertical cut. So I might just go back into the tree, make sure I activate the next open cell in row 2, double-click on Cut Extrude 6, double-click on the mirror, and we could get that data in there. I already had it. That's why it didn't get added right there. And I already had the mirror in there. So we're just going to unsuppress, unsuppress, and I'm just typing in use, suppress, suppress. Anything that's blank for suppress and unsuppress will be unsuppressed by default, so I want to make sure to key that in. Those are some other cuts. That's cut extrude 5. We want to suppress that. And for all the others, I'll leave the defaults, and I'll just leave them blank, and that'll just leave the current value. Click outside the table, and we'll see a window pop up to build a new configuration. And activate. There it is. So I didn't get it quite right. I did make a couple of mistakes, but you can kind of see how that behavior works. So what I want to do now is I'm actually going to shut this part down and reopen it so it doesn't have any configurations, and really start this design table process from scratch. So we'll go through that same operation. But before I do that, I'm going to take a little bit of my own recommended advice and rename the features and rename some dimensions that I want to control. So I'm going to right-click on the annotation folder and say Show Feature Dimensions, and it gets a little bit messy up on the screen. I will go to the Hide Show Eyeball items, and in the right-hand column, say Show Dimension Names. And there we see dozens of D1s and 2s and 3s and 4s. Any dimension that I'm thinking about controlling in this design table, I'll just double-click on it. But I'm not actually going to change it. I'm just going to type in a new name in that upper window, and we'll say that's the width dimension. And we'll say OK. And maybe I want to control this, which is the vertical spacing between the holes. Again, this is one way to do it. Just double-click, type in a new name. We'll call that the offset. And as many dimensions as you would like to change, you can change. And you can see that their name is now distinguishable from the D1, 2, 3, 4 kind of fuzzball of dimensions that'll pop up there. Features that I would like to control, maybe I'll rename those as well. So just I'm selecting and hitting F2. Maybe we call those the end holes, et cetera, et cetera. I'm taking it a little bit to the extreme since I am renaming every single feature, but it is an option. And it does make it, at least in my opinion, a little bit easier to figure out what's what. So now I've got some renamed features that I want to control, some renamed dimensions that I want to control. Now I'm ready to create this design table more or less from scratch. So I'm going to position the model over to the right, go through the process again, Insert Tables, Design Table. I'm going to turn off that cell, drop down again, say OK. And we'll see this this selection box. And now it's much easier for me to pick out the dimension or two that I want to control from, again, the D1s and 2s and 3s. I did not, in this example, rename the sketches, but I could have, and that way I wouldn't see Sketch 1 and Sketch 2 and Sketch 3. I would get some very important information there. We'll say OK. And just the dimensions that I selected to control are added into the design table. Again, I'll make the font a little bit larger, resize things so hopefully it's easier to see. Activate the next cell in row 2, and then double-click on a feature I want to control. Cut extrude 1 and the end hole. And maybe I want to create a configuration called the blank again. And I'll just tab across. And instead of typing in suppressed, I'll just put it in as a simple S. So S for suppressed, U for unsuppressed. It allows you to have a little bit of a tidier table. Again, just activate the next open cell and start double-clicking. So we could grab the large cut, we could grab the slots, and so on and so forth. But this is what makes design tables so cool. Because it's Excel, we can just copy and paste to really propagate this data, quite effectively. So the blank, everything's suppressed, and we'll just keep that going on here. Keep everything suppressed there. Oops, I accidentally copied empty space, so that's not going to work out too well. There we go. Click outside the table, and we'll build a new design table. or that configuration. Notice the two dimensions turn from black to pink. That signifies they are being controlled by the design table now. If we would like to go back in and edit that table again, right-click Edit the Table, either in this separate or this internal window to SOLIDWORKS, or if you have dual monitors, it does work quite nicely to edit in a new window. It's going to be hard for me to show that, so I'll edit everything within the same window. And that all-important right-click the design table and then save the table. It'll load it up and choose other parameters to add, the color, the part number, the description, other dimensions that possibly we would like to control. Just click on them and say OK, and it's added to the table, and then save that table right there. Again, very important thing to do, even though I did not do it there. A few more configurations we may want to create. I don't think I've made this one with the slots, so I'm just going to, basically suppress everything to begin with, and then find the slots and select that cell and unsuppress it. Just type in a U. I don't think I made one with the large cuts through a design table, and we'll kind of do the same thing. Oh, we need these unsuppressed for the slots. We need those unsuppressed. But even if you just manually type things in, you can go, at least for me, too fast where I get a little bit confused. So even kind of a slow manual method, it's it's a pretty fast way to get things built. Every time you click out of the table and back into the SOLIDWORKS window, it will give you a message that it built the configurations, and this list will simply get larger and larger and larger. And we can continue this process on and on and on, but that's really what it all comes down to. Now that my design table is a little bit more intact, I will save the table out. Again, it's quite important to do so. We'll save it up on the desktop because that's just an Excel function. Now that the table is deleted, let's say we wanted to, the table is saved, we could then delete the table. Be careful about this. You can see it cannot be undone. So there we go. There's our nice table right there. So we could go ahead at this point, if we're satisfied with our nice little configured part and our nice little design table, go ahead and save everything and take a look at that. So wrapping things up here, yes, I do realize I spent quite a bit of time just on the backgrounds of configurations and getting in here towards the end on design tables. But this is something that comes up quite common in how do we get that table into our drawings, and more commonly, how do we format it correctly? Because they are a little bit tricky to format. And what I want to emphasize here is when we go through this operation, it's just a spreadsheet brought into the drawing through OLE. So we do have to work within those limitations. There is a cell limit for as many columns wide and cells and rows you can have. There's a limit based on OLE to the size of the design tables. And what we see, as we'll see here in just a second, is exactly what we get inside the drawing space. So here's our part. We'll make a drawing from the part, and we'll go ahead and just simply drag in a view. And I don't believe an A-size landscape is quite large enough, so let's go to the sheet, right-click Properties, and we'll just switch it over to a B landscape. So I have a bit more real estate to work with. From this point, we just go the same way, Insert, Tables. But notice that the design table is currently grayed out because I did not pre-select the drawing view. As we all know, you can have many different models, many different files with and without configurations, with and without design tables inside a single SOLIDWORKS drawing. So we need to make sure to tell the software what we're working with. And there's the table. And I think we'll all agree that the formatting on that table is quite poor. So again, it is just an OLE table. If you right-click, You'll see kind of the typical OLE options, edit and worksheet. We can also simply double-click, and that is the same as edit and worksheet. And notice what happened. It opens the part. It edits the Excel table inside of the part. It gives us options to bring other parameters into that design table as if we never created the drawing. So it really keeps going back over and over and over to that Excel spreadsheet inside the drawing. So this is what we need to clean up. So I'm just going to select all of those cells to kind of auto-compress them. You could add your own borders in there. You could add internal borders, all that good stuff. But it is important that you do resize this kind of hard border of the Excel window, because that's one step too far. I accidentally clicked out. But whatever that shows inside of this environment is exactly what you'll see inside of the drawing space. So sometimes it is a little bit tricky to work with. So just have some patience. Make sure that it is the right size. Also notice, once it rebuilt, it recompressed everything, so you might want to lock the sizes of those cells and things of that nature. So we switch back to the drawing. It is important you must rebuild, because it's got to reload all that design table data. And it should look a bit tighter. Now, I did not get it perfect, but you can see, at least the border in there. You can hide that cell so it doesn't say design table for the file name. And I needed to do a little bit better job about tucking that bottom window up there. But at any time, you can go ahead and edit that worksheet. I do want to point out, though, you cannot save the spreadsheet from this environment. You need to switch back over to the part, right-click on the design table in the configuration tree, and save the table. So they're pretty easy to get in there, maybe a little bit awkward, cumbersome to resize. So again, whatever the table shows, whatever font sizes, whatever cell spacing you have in the model, that's exactly what you're going to see when you show that design table over on the drawing. Of course, you can hide cells. You can add your own cells, and you can get, again, very clever with how these tables are displayed within your environment. So I've been talking for quite a while. I'll just recap a couple of points here. Design tables and configurations are quite powerful tools in SOLIDWORKS. You can go really as complex or as simple as you want, but it does require a quite robust model. Typically, I like to build them with more features. Rename what you want to configure, features, dimensions, show that information, especially with working in a design table. It really does help quite a bit. Even more so than just strictly configurations. With design tables, if you're not familiar with them, start small. Maybe brush up on some Excel functionality. If you're like me, that's definitely a good thing to do. Have a plan, and large table or small table, save a copy of the table. If it's an external design table, save a copy of that external design table. We don't want anything unfortunate to happen to these tables. That's for sure. So as we wrap things up, I just want to mention a couple of webinars we have throughout the end of July, which we're almost there, and the beginning of August. We have our hardware webcasts with some new functionality with the Stratasys machines on July 30th. We're going to have a Visualize Professional webcast on August 15th, and the next CATIpult, the next kind of technical how-to session we have, is going to be sheet metal basics. We've had a lot of requests for just show us some kind of getting started sheet metal functionality. So that's what we're going to cover in August, or towards the end of August there. So to finalize, I do want to say thank you very much. I see a lot of familiar names in the list, so I appreciate you coming back to the webcast over and over and over. They're a lot of fun, a lot of enjoyment on my part. And if you have any comments or suggestions about webcasts, send me an email. Love to hear from the customers, especially if you've got some good ideas about what we could show. Everybody uses SOLIDWORKS differently. All you customers, all you users use it very, very differently. So if there's anything you'd like to see, give us a holler. We'd love to put something together if we can. And with that, again, thank you very much. And if you have any questions, fire them away on my email. I'll leave it up there for a few minutes. And I'll say, everyone have a great day and a very nice weekend.